Hi, I am Simon Stewart. If you've got incredibly exceptional eyesight, you can see that I am a software engineer in London. If you haven't, I am a software engineer from Facebook's London office. And I'm here to talk to you about how open source powers Facebook on Android. We're going to be covering a lot of stuff in this talk. We're going to be going all the way through Facebook and its involvement with open source technology, through the build tools we use, through some of the libraries we've open sourced as we've been developing our Android application, and ultimately going through how we do our continuous builds and organize our source tree and handle DVCS and other exciting things. There's going to be lots of stuff in here. If you've got any questions at any time, just raise your hand and wave it around, and I will point at you and try and get your question. Otherwise, at the end of the talk, there's going to be some time for you to say what it is that you need to say. I am on Twitter, even though I work at Facebook. That's my handle, SHS96C. Don't ask why it's like that. It's a long story. And this is Monkey and Bunny. They're my son's favorite cuddly toys. Whenever I go away traveling, I tell him that I'm going to give them an adventure, and they'll send him photos and stuff like that. So they're here with me. So, Facebook and open source. When I joined Facebook in 2012, I really didn't think of Facebook as a major open source player. Right? I just had no idea how much they do. But recently, especially over the past year, we've revamped our open source efforts. There are something like 200 repositories in our GitHub area. So if you go to github.com/Facebook, 200 separate open source projects. In those 200 projects, in the first 6 months of 2014, there were approximately 13,000 commits. That's a heck of a lot of code landing in there. And not all of that work was done by Facebook engineers. We are firm believers in open source as a collaborative process. And in some of our repos, actually, external contributors outnumber the number of patches being delivered than by internal people. In those 200 repos, there are approximately 9.9 million lines of code. We should have worked a little bit harder to make that a round number. But that's a lot of code, right? And they're scattered through a number of projects that you may or may not have heard about. Has anyone here done any front-end development in JavaScript? Yeah, some of you have. You may have come across React, which is a sort of super fast library for doing really nice, slick DOM manipulations. We use it extensively on the Facebook site itself. Libraries from our iOS apps, from our work on Paper, in particular, Shimmer, Pop, KVO controller. These are sort of very popular open source libraries for iOS. HHVM, Hack. The hip-hop virtual machine is the server process we use on our back-end servers. Hack is a superset of PHP that introduces typing so you can be more efficient in how you run it. Presto, Warp, Haxel, these are all tools that we use on the back end. If you're into big data, Presto is really interesting. Ad hoc queries over your Hive data sets. Warp, Haxel, just really useful developer tools. And there are loads and loads of separate tools. As a personal note, almost every line of code that I have written since joining Facebook in 2012 is available as open source. There are many companies that allow us to make that sort of commitment as engineers to participate in open source communities. And I feel really lucky to be in a company that allows me to do that. But, you know, we've done all these separate projects, right? iOS, the front end, JavaScript, back end servers, but you're here to listen about Android. I hope you're here to hear about Android. If you're not, just stay sitting down and give me a high score at the end of all this. There are some things that you may already know about Facebook's Android app. It's big. It's a native application. We originally had a version that was sort of wrapping web views and HTML, and that allowed us to iterate really, really quickly. But it wasn't giving users a really great experience. And having a fantastic experience when you're playing with Facebook on your Android device is really important to us. So we went for a native application. There are literally hundreds of engineers scattered in 3 major offices around the world working on the Android application. Every 4 weeks, we do a release. I'll be covering our release schedule later on. And Facebook on mobile, so that includes iOS as well. There are over 1 billion monthly active users. That's a terrifying number of people. In fact, in some places, there are more mobile users than there are desktop users. The world is going mobile. We need to get this stuff right. So, how do we build Buck? Quite like that slide. How do we build Facebook even? The main thing that we use as our build tool is one called Buck, which we open sourced about a year ago. Has anyone done any work on an Android app using Ant? Or maybe Maven? Gradle is the super popular one these days, right? Those build times, are you happy with those build times that you're getting out of that? Yeah, no one is happy with the build times. Like, builds are always too slow, right? You want them to be instantaneous. Buck is a sort of next generation build tool. And the way it works is that rather than having a series of steps that it needs to perform, you break your application up into modules. Normally those are in the Java packages. Here you can see a sort of virtualized diagram of a project. AL, an Android library, Android binary. We can execute arbitrary chunks of shell in a general, a GR. And you'll see that we've formed a directed acyclic graph. And what happens is Buck will read the build files scattered through your project, build this acyclic graph, and then figure out the most efficient way of compiling your application, taking advantage of all the features of a modern machine. So your average modern machine has multiple cores that may not be running particularly quickly, but it's probably got somewhere between 4 and 8 of them if you have hyperthreading enabled. You've probably got an SSD instead of a chunk of slowly spinning rust with a needle poised just above it. And you've probably got oodles of memory as well. So we take advantage of all of these things when you're building with Buck to drop the build times. Now, we used to use Ant at Facebook. And when I joined, we were just making the switch over from Ant to Buck. And what happened was our developers, when they ran their Ant build, when we were doing the switch over, they go Ant build whatever it was. Be a little message that would appear at the top of the console. By the way, it would say, what you need to do is clone this Git repo, CD into that, build this target, add this to your path, come back to this directory, run this command, Buck build the Facebook application, and you could perform all those steps, and Buck would finish its build before the original Ant build that you kicked off had finished. It was that much faster. It was like a quantum leap forward. Fantastic. So how is Buck so fast? The first thing is we treat your build as if it were a set of functions. So for the same inputs, you're always going to get the same output. That allows us to do a bunch of optimizations. We've made changes to DX and... Oh, wow, that was weird, wasn't it? We made changes to DX and ProGuard for faster compilation. We run DX in memory. We keep it held and resident, and that allows us to slash the time it takes to dex a library by somewhere in the region of 60 to 90%. And it's better, the smaller the library, the bigger the gain, which is lovely. Java has a concept of an ABI, an application binary interface. If you modify something other than the public contract of your classes, if you add a new logging line, rather than having to recompile the entire project and everything that depends on the library that you just modified, if you haven't changed that public contract, then we only just repackage the app after compiling the one library that's changed. And that manages to make your incremental builds incredibly fast. We also do something similar with Android resources. We're very clever about how we manage them, and we can reorganize the build tree in order to front-load some of the work that needs to be done there. And we take advantage of a daemon to watch the file system for changes. It's called Watchman. I'll be talking about it later as part of later on in the talk. But that allows us to be notified when we kick off a build of, hey, what's changed since the last time I did a build, rather than having to walk the entire file system. If you've got a large project, that can save you a lot of time. Incremental builds are really, really important to us. We want our developers to be able to go as quickly as possible. We want you to be able to go as quickly as possible. And literally this morning, we pushed a new feature to the world, which has enabled us to save so much time. We call it Exo Package, and it's an optimization for building and installing development versions of your Android app. So you know when you're working in your app, you make a change and you want to check it out, make a change, you want to check it out, make a change, you want to check it out on the Android device. Installing the APK can take, I don't know, 20, 30, 40 seconds. It's an incomprehensibly long time, right? Just, you know the XKCD cartoon where they're sort of fencing on chairs? Very much like that. We want to avoid that. We want to make sure that computers are waiting on people rather than people waiting on machines. So what we do with an Exo package is we take the Java libraries in your project, We shard them up, and then you basically have a wrapper that's a fairly simple stub that reads these things from disk, and we can just copy over the individual files that have changed. That allows you to have incredibly fast install times and incredibly fast incremental builds. To give you an idea of the kind of speed you get out of it, a clean build of a popular Android podcasting application, built using Gradle, 33 seconds. A clean build using Buck, 6 seconds. So that's 5 times speed up. An incremental build where you just make one change and you push it to the device, 17 seconds to, that's not a typo, 1.7 seconds. It is literally 10 times faster. And the no-op build, because we're using a daemon to watch the operating system, almost instantaneous. It's a fantastic piece of kit. If you're interested, by the way, in Exo Package and taking advantages of this for yourself, it's a feature of Buck. So check out the Buck documentation, and in particular, this new Exo Package.html page. It's going to contain a lot of information. Buck also can take advantage of distributed caching. We have hundreds of engineers. There are people doing lots and lots of work. Now, when you're creating a new feature, you're probably only modifying like 1 or 2 files, and everything else in the code base is exactly the same as it always was, and it's kind of tedious to wait for that. So we use our continuous build infrastructure to warm up a cache. When we do a build, we drag down the 97% of repeated work rather than building it locally. And that allows us to go at a phenomenal speed. Somebody wrote on the engineering lists recently, he went, the build of this application, which is big and complex, goes, it takes 40 seconds. Is there any way you could speed it up? It's like, yeah, we're working on it. The caching is the thing that allows us to do that. Without it, the build would extend to minutes. So that's Buck. Android has been around for a while, and every time they do Google release a new version, there's something interesting in there that you need to pay attention to. These are some of the highlights of the last releases, from Gingerbread all the way through to the new one that's coming out at some point called L. You can all read. I'm not going to read it out to you. There's a couple of interesting things, though. WebM support, the ability to access the SD card in Honeycomb, the multiple UI refreshes. Like, crikey, there have been 3 that have come through. Chromium Web Views, new APIs for messaging and storage, so you could do SMSs. But what we want to be able to do is, if you have the Facebook application, you should have a consistent experience. It doesn't matter whether you've got a standard Gingerbread phone. Those things are still out there. Or if you've got the latest, greatest KitKat. Or if you happen to be an early adopter and you're running like the early betas of L. We want our applications to be consistent, and we want them to perform in a reliable way across all the different versions of Android that are out there. And so a lot of the libraries that we produce cover up the differences and allow us to be consistent across the entire range of supported Android versions. When we create a new application, one of the first things that we do is mock up the UI. We use a tool called Origami. This came out of the work on paper, but we've used it on home as well. Origami is a set of patches for Quartz Composer on OS X. And it looks a little bit like this. This is obviously Quartz Composer here. And what this allows us to do is quickly mock up how we expect the interactions to look, how we want them to feel, the speed with which we want things to do. So you can get that look and feel of the application, because you want your applications to be silky smooth and fun and playful and enjoyable to interact with, right? So if you want to just practice some of this stuff without having to do reams and reams of coding, and you've got a Mac, check out Origami. That's what we use for just mocking up our UIs. Because once you've got the UI, you probably want to build it. We released an open source library called Rebounce that gives you playful spring dynamics. And it uses the same spring dynamics that we've got in Origami. So if you've done your UI prototyping in Origami and now you're trying to reify that in the application itself, you can use the Rebound library, and that will make it super nice and give you those nice little bouncy animations. It's really easy to use. It's only a handful of lines. This top line sets up a new spring system. Here we can change the state of a spring, so we can go from one state to another. And then you can register a listener to do interesting things. In this particular case, which is what this demo here is showing, we're rescaling an image as the size of as a spring bounces backwards and forwards. And we're also plotting it on a chart. The nice thing with Rebound is if you're doing web-based work, there's a version of Rebound available in JavaScript. It's a lot of fun, right? And you want your applications to be fun and playful. But you also want them to be secure. Particularly on older Android devices, internal storage is a rare commodity. It runs out. There just isn't very much of it. And it'd be really nice if you could store things on the SD card. The problem is that if you're storing things on the SD card, it's insecure. Someone might take that card out. They might read it. That would be awful. So you want to be able to store fairly large amounts of data on a card that might be removed. How do you do that in a secure way? You can use a library like Conceal, which takes some of the algorithms from OpenSSL, implements them, and makes them available on Android. Now, this isn't a general-purpose cryptography library, so it isn't equivalent to Bouncy Castle, but what it does do is it allows you to secure your user's data on an SD card, and that allows your applications to offer more functionality, offline capabilities, and things like that. We use it in Facebook's application itself, and it's an open source library that you can use as well. Hopefully, you'll find that useful. For the last bit of this talk, I'm going to talk about our source control and code review, testing, and how we do releasing at Facebook. These are all things that hopefully you can take advantage of. Source control. We have, 10 or more applications for Android. All the source code for all of those applications is held in a single source tree. I ran some numbers over the top of it. There are hundreds of thousands of files in there. That's millions of lines of code. It's a large amount of code. And I can't tell you the official number, but I can tell you there's more than 2 commits a day into that code base. It changes fast. The problem that we had is that we were using Git, and before that Subversion, and we were finding it hard to scale. Like, so many people checking in so much code on such a huge code base. Like, how are we going to be able to move forward? So we did some analysis of the various tools that were out there, and we decided that we were going to take advantage of Mercurial. And the main reason for taking advantage of Mercurial is it's got this very simple, consistent internal model and set of APIs for dealing with your source code and the changes within them. It's easy to extend. We're pretty committed to Mercurial. Facebook has donated over 1,000 patches over the years to the project. We've hosted the last 2 Mercurial sprints. That's where we gather the Mercurial developers into one place, and they can all argue amongst themselves and, steel cage knife fight their way to determining what the latest, greatest piece of functionality ought to be. So we've hosted those at Facebook's headquarters and one in London. And we've open sourced 2 Mercurial modules that have enabled us to really scale up our infrastructure and take advantage of the just huge number of people we have. First one I'm going to talk to you about is HG Watchman. Watchman is an open source library available. It runs on Linux and it runs on OS X. And what it does is it provides a consistent and uniform interface for being notified of changes in the file system. So you can be notified of when someone's written a new file or when something's moved and things like that. You may have used iNotify, or I think there's an equivalent on OS X. They tend to be a bit lumpy. They tend to have weird corner cases. Watchman smooths those out and provides a consistent API that runs across multiple different platforms. Here you can see the performance gains that we got by switching from pure Mercurial to Mercurial backed by Watchman for a series of our operations. Status, it was a fraction of the time. Diff is approximately a quarter. Checking out the code amazingly becomes faster, and commits as well. So you get a real time saving when using Watchman on your local machine, even if you're not using a massive distributed thing. Even if you're the only developer working on it, you can still get some benefits out of switching to Watchman and Mercurial. And we've got a large repo, right? Hundreds and thousands of files. And there's sort of something tedious about a large repo. They're slow. Pulls are slow. Checkouts are slow. With years of history, we've been developing our Android app for a long time now. You'll find that clones are slow, and they require this vast amount of disk space. And that impacts both developer productivity, means you need meatier developer machines, and it impacts your build infrastructure. It means that your continuous builds take longer. We decided that this wasn't good enough, and we wanted to do something about it. Within Mercurial, there is an abstraction called file log, and that contains a reference to the contents of the file and all the different versions that there are. And what we did is we released a module for Mercurial called Remote File Log, which allows you to keep that data stored on the remote machine. So when you do an HG clone or a pull, we just grab down a chunk of the metadata. We don't download the file contents, we don't download the history, we just download the metadata. And that means that your clone times shrink dramatically from tens of seconds to a handful of seconds, if that. Rebases, pulls, they become fast. It's only when you perform an operation that requires a file, like an HG checkout, that we actually go and download the actual data. And we can, when we're downloading that data, take advantage of memcache, for example, to allow nice, fast serving. So the day-to-day operations of a developer go from being quite painful and tedious to being fast, efficient, and taking good usage of the infrastructure that we have available to us. Obviously, DVCS, one of the pleasures is you could hop on an aeroplane and you've got everything you need there. Remote file log, you can't hop on an aeroplane, but fortunately most of our developers sit at a desk every day, and very few of them are airborne at any one time. So that's Mercurial. Code review. Every single line of code that goes into Facebook is reviewed by at least 2 people, the original author and one person doing a code review. The tool we use for doing our code reviews is Fabricator. In the Java world, they put a J on the end of things. In the PHP world, particularly with our open source libraries, apparently we replace Fs with PH. So that's Fabricator for you. It's a really nice tool. You can see here that Roy has put forward a new diff that needs to be done, and he said his entire test plan is he's going to build the application. That's not very good. Michael here has said, can you make some changes? So on and so forth. Now, that's fairly standard for a code review tool. I'm sure you've seen something similar in like Gerrit or Rietveld or some of the other tools out there. The killer feature for Fabricator is animated GIFs. They say a picture is worth 1,000 words. There's like 7,000 words worth of explanatory text on that slide alone. 1, 2, 3, more than that. Lots of words. This is a fabulous way. It seems frivolous, right, and childish and petty. But, Christ, writing software is so much fun. Code reviews can be entertaining as well. We also need to test our software. Obviously, there are multiple different kinds of tests. Everyone names it differently depending on what company you're in. We use the terms unit, integration, end-to-end, and to a certain extent, manual testing. Unit testing, just a single class in isolation. You can do this with integration testing as well. We use JUnit. It has nothing to do with the fact that Kent Beck works at Facebook and he wrote JUnit, although he does work at Facebook and he did write JUnit. And that's kind of nice. We use Roboelectric to save us having to push code all the way to a device or an emulator in order to test it. If you're not familiar with Roboelectric, it came from Square, and it's an implementation of the AOSP that runs on the JVM. So you can just do all your testing. You can actually do TDD on Android using this combination, which is obviously allows you to move faster and write more code and be more effective. For our end-to-end testing, we use Selendroid. Has anyone here heard of a project called Selenium?
Yes.
Okay. I am the project lead of Selenium. I invented WebDriver. Selendroid is an implementation of the WebDriver protocol designed for mobile devices.
So it uses the GNU installation?
It uses the same APIs. So if you've used like WebDriver...
Does it fire up a VM? Just curious.
Does it fire up a VM? No, that you have to manage the VM yourself. But you could use...
The VM have to be open in order for Selendroid?
Yes, you need to start the VM. Yeah, so assuming you've got a device or something running on it, you've got the application deployed, you can say to that, like, click on this element, find this button, make sure this text is visible on the screen. And Selendroid allows you to test not only native applications, but web applications and also hybrid applications running on your Android device. And it supports everything from Gingerbread all the way through to L. So if you want end-to-end testing on Android, have a look at it. We quite like it. It's good. Interestingly, I didn't start writing this. It was originally started by a chap called Dominic Derry, who works at eBay. And so eBay and Salesforce have actually done a huge amount of code on this as well. One of the nice things about open source, get to work with all these really clever people who are passionate about solving problems that you wish that had been solved already, and it turns out they've done it. So we've written our tests. We need to make sure that they run. We use BuildBot extensively at Facebook. You can think of BuildBot as a library of tools for building your own continuous integration frameworks, right? It isn't like Jenkins, for example, where you just unpack it. Yes?
How many instances of VCS does Facebook use?
How many instances of VCS?
I see you list a lot.
Yeah, we've gone through some migrations. I believe well before I joined the company, it was on Subversion because everyone used Subversion back in the day. I don't think they ever used CVS or anything like that. We made the move to Git. Git was wildly popular, but the problem that we found was that Git wasn't scaling the way we wanted it to, and we couldn't make the changes that we really wanted to in order to properly support our users. And so we took a look at Mercurial, and we're now migrating everyone over to Mercurial. So yes, there are a lot there that I mentioned. This diagram comes from the BuildBot homepage. So these aren't necessarily the things we use at Facebook. These are the things that BuildBot will work with. Hopefully, you're all on either Git or Mercurial. Like, we're all developers in the 21st century, right? We should all be using a DVCS, or perhaps Subversion. So BuildBot works with all of these different source control systems, and it can notify you in a number of ways. We've actually hooked our BuildBot up to Fabricator, so when you're doing a code review, you can see whether or not particular continuous builds have failed or passed, and that can save you time. Like, why bother reviewing code if you know it's broken stuff, right? That sort of integration allows us to continue moving nice and fast. BuildBot, definitely worth a quick look if you are looking at continuous build system. So releasing. On the web, we release twice a day. We do a major push once a week, but every day, twice a day, we push. We can't move that fast on mobile. It would be really nice if someone figures out how to do that. Do let us know. But what we do is a 4-week-long development process. Now, the nice thing with a time-based process is that you know that if you miss this current release, you'll be in the next one, and you know when that next one will be. The other way of doing software, if it releases, if you're not doing time-based, is feature-based. Does anyone work on a project where features are delivered on time, to schedule, and bug-free? No, I didn't think so either, right? Feature-based releases are a recipe for unhappiness. Like, you just do not know when your next release is going to be. So time-based is what we picked. And it brings some regularity and reduces the stress and strain on the developer. Like, they know that if they miss this, there's going to be something coming up. So every 4 weeks, what we do is we cut a release branch, and we have about 3.5 weeks of stabilization. I'll be covering how we do that in a minute. For the final half week, we have a release candidate, and that release candidate gets pushed to everyone to use, and that should be stable. As we find and fix bugs, we fix them on our master branch, and we just push them down onto the release branch. Now, I know that we're using a DVCS, and DVCSs allow you to do absolutely crazy branching strategies. This is it. At Facebook, we have basically 2 branches. The master branch, where almost all the work is done, and the release branch, where our release managers do the care and feeding. Stabilization, how do we do that? We do it in 3 ways. We dog food extensively. Dog fooding is a charming term that I believe came out of Netscape. It's eating your own dog food. Hopefully it tastes really good. It means effectively using the software you're going to make everyone else use, right? So there are masochistic and enthusiastic Android developers who are testing with the very latest version of Master on their own devices. We dog food extensively. Every single member of Facebook who uses an Android phone is asked to use the release candidate, and we do the same on iOS as well. Everyone is using the release candidates if they're a Facebook staff member. You can also take advantage of that, right? Google have alpha and beta channels that are available for Android applications, and we make extensive use of this. The alpha channel is basically a cut of master that we push every single night to people who are using it, and I believe we do beta about 2 or 3 times a week. So if you're not quite ready for the really bleeding edge, but you want the latest release of Facebook before it comes out, you can sign up for the alpha and the beta channels. You'll get that available to you. It doesn't overwrite the production app, so if you find that we have somehow managed to release a bug that's getting in your way and preventing you from doing things, you can fall back to the production app. So that's how we do the manual testing. We don't have a QA team, right? Our QA is entirely done by employees, and it's done by beta testers and alpha testers. We rely heavily on our automated testing. And the reason for that is that our release cycles are so fast that there just isn't time to put in a full manual QA cycle, right? We need this automation, and that automation is powered by open source. Okay, so I think I've got about 10 minutes left. I'm happy to take any questions that you may have about how we do software development at Facebook or on Android, or anything that I've raised here. You seem quite interested in the WebDriver stuff. Gentleman there.
Could you tell us a little bit more about how you do your code reviews?
Code reviews?
Yeah.
Sure. So Fabricator is the tool that we use, and it comes with a command line client called Arc. And so what happens is you hack in your code, you like git, checkout, commit, okay, I think I'm ready. We squash everything down to a single diff, and then you do like arc diff, and that's a command line integration with Fabricator. And what that does is it pushes your diff up to Fabricator, ready for review, and then you can select who's going to review it. Normally that's somebody on your team who's familiar with the code, because you don't want someone coming along going like, what are you trying to do? They might do that, right? But at least if they're on your team, they're familiar with the madness that you write every day. They then take a look at it, and there's basically 3 things they could do when they look at your diff. The one you're hoping for is they go, yep, ship it. They go, yep, you can commit this. And when they commit it, we've got commit hooks that make sure that every single piece of code that you check that lands in the code base has got a green review. They can comment on it, so they can go like, I'm not so sure about this. Or they can request changes, and that's normally the very first thing that happens. In that slide that I showed you, the red, where Michael was replying to Roy, Michael was asking for changes to be made. And it might be, look, you've misspelt the word cucumber or whatever it is. It might be the algorithm you're using isn't terribly efficient, you could do something different. Or it could just be, can you fix up some of your spacing or whatever it is. So you tend to go through 2, 3, 4 cycles of that. With really contentious diffs, it can go on for a long time. Sometimes it's just like, look, this is fine. You can land it. If you really don't understand what's going on, you can dog science it. So you can say, I have no idea what's going on, but I trust you as a human being. I've read the code. It doesn't seem actively malicious, and you tell me it works. Brilliant. That's really rare. Like when we do pushes of documentation, that's quite common, right? But yeah, you've normally got this sort of interactive review process. You can specify 1 or more reviewers, and then Fabricator allows you to say, I'm interested in this part of the code base. So you can set up rules so that if anyone checks in or tries to check in a diff that touches something you care about, you can be notified about it. Does that answer the question?
Yeah. Do you make differences between senior and junior developers? Or?
Do we have differences between junior and senior developers? It's interesting. I used to work at Google, and at Google everyone had like different levels. And because that's a separate question, and I'm happy to talk about it later. But let me finish answering this one right now. At Facebook, everyone is a software engineer. We don't really know the levels of everybody. And that's really nice, right? Because you're just working with a group of your peers, right? There's no fighting, there's no arguing, there's no nobody pulling rank or anything like that. Tech lead is a sort of a role you assume temporarily on a project, because you happen to be the person who's most capable of leading the code at that particular time. But it doesn't mean that it's the most senior engineer. It could actually be a relatively junior engineer, just has a really good idea about how the software should be written. So you very seldom get people pulling rank or doing things like that because we're just not aware of it. And I really like that sort of collaborative, equal feeling that we have in the company. Yeah, I know that sounds a bit motherhood and apple pie, but there we go. Gentleman there, and then you after that.
How do you manage keeping in sync with the iOS team or the backend API team and manage the process between from an Android team perspective?
Yeah. So obviously there are changes where. Can I repeat the question? How do we stay in sync with the iOS teams and the web teams as well? Because obviously there are changes happening in all of our code bases. The main one is there are a few things that we do. We used to have an iOS team and we used to have an Android team, and we found that really didn't scale very well. So now teams own particular features. The Photos team owns photos on Android, iOS, the web, all of that. So they get to allocate resources within their team in a sort of sensible and meaningful way. That means that they achieve parity on the different platforms. We released Thrift a long time ago, which allows you to do message passing between the applications with a concrete message, which is under version control. And there are other libraries that we use and provide sort of similar functionality. So the main change that you need to do is just make sure that sort of when you make a change on the web, that existing clients continue to work, which we can do with our extensive manual testing and automated testing. And yeah, I mean, it just works, right? We don't give ourselves additional problems. Like, I think some companies, like Soap was a nightmare. I remember developing Soap stuff, and thank heavens we don't touch any of that stuff. It's all sort of these concrete, strong types, and JSON is very popular as well. Does that answer the question? Okay, excellent. There was a gentleman there.
Why don't we use some commercial solution or commercial tools?
Why don't we use commercial tools for what?
For testing or for building?
Why don't we use commercial tools for testing or building? So it turns out the open source tools are some of the best in the world. That's the reason. We use the best of breed tools, and it turns out the best of breed tools are open source. The best of breed open source control systems, Git and Mercurial. Maybe Perforce, right? But Git and Mercurial DVCSs, there really isn't anything commercial on the market that compares with it. When it comes to automated testing, there's nothing like JUnit has commoditized the testing space in Android in Java. End-to-end testing, I'm not aware of commercial tools that allow you to do TDD in the same way that Selenium does, in the way that the WebDriver APIs allow you to do. So every single time we take a look at things, we don't pick open source because we're zealots about open source. We pick open source because it's the best way of solving the problems we have. And then we commit back to open source because we're part of a community, and you can't just keep on taking. It's only fair and right to be part of the community you're sharing with. Does that answer your question? Excellent. So gentleman at the back, and then I'll do you next. Do we use Espresso for testing? So for those of you who don't know, Espresso is an end-to-end testing framework released by Google. No, we don't, is the answer. And that's because Espresso only works on the very latest releases of Android. We have to support Android all the way back to Gingerbread. Espresso doesn't run there. It would be nice if we could ignore that. But until Google managed to persuade everyone to do upgrades at the same rate that Apple do with iOS, we're just going to have to use tools that are capable. The other reason, by the way, is that Selendroid doesn't get deployed to the device, right? Your test lives on your local machine, so you get faster cycle times as you're experimenting with your end-to-end tests. And sometimes that's really important, particularly as you're trying to write these things in the first place.
What are some of the reasons why you decided to go with native apps for iOS, Android, instead of going across platforms, just having one code base?
What? Okay, so to repeat the question, why did we choose native apps instead of cross-platform ones? Yeah. So when we were doing development where we were effectively wrapping a web view, there was a lot of stuff that played really nicely to the strengths of Facebook. Like, we could iterate incredibly quickly. And if we discovered a bug, we could fix it on the servers, and then everyone all over the world would have those. But it turns out that actually the user experience, like just consuming the application and using it day to day, was just unpleasant, right? The HTML engines were relatively slow. I mean, it's only in KitKat that you've got a Chromium-backed web view, right? And the JavaScript engines were really slow. I don't think you've yet got a jitted web view on iOS, right? So, it's a slow experience, and we want people to have like happy, natural, playful, engaging interactions with the application. And at the time we made the switch from HTML to native apps, the only way to do that was through a native application. Obviously, we quite like that fast iteration. It's something that I think we consider every now and again, but for now, a native application is the way forward. Gentleman at the back, and then in the blue shirt, and then the lady, and then I think we're going to be out of time for questions.
So besides dog food, how are you handling things that are kind of, since you're not doing official QA, things like power management, maybe security, data at rest? How's that handled? How's that integrated?
So how are we handling things that are traditionally handled by a QA team? Yes. We bake them in. We've got engineers who are working on site integrity, SI. We've got engineers who care passionately about power consumption. The interesting thing that I find is that in a traditional company, you find that QA is sort of bolted at the end of the development process. Like, you can't bolt on quality as an afterthought, right? It's got to be something that's baked into the application from the very beginning. It's a bit like saying, oh, yeah, I'm going to write it, and then I'll make it perform well. Or I'm going to write it, and then I'm going to make it secure. Right? It just doesn't work. And so the things where you would expect people to be passing it off to the QA team, we actually have engineers who are just passionate about those particular things, who are focused on doing the things they need to do. Interestingly, they tend to write automation. So we've got automated power management, we've got automated performance metrics, and we've hooked those into BuildBot, and we get feedback like if your change were to bloat the size of the application by a couple of meg, or if you were to introduce a performance regression, we get notified by our continuous builds. Does that answer the question? Excellent. Gentleman in the blue shirt.
How and when do you make the decision to drop Gingerbread and so on off your list?
Well, I think the way that everyone should be doing it, which is with data. Like we'll take a look at the usage of Gingerbread, and at some point it's going to fall below some critical threshold, and I don't know what that threshold is. We only recently dropped Froyo support, though. Like, it turns out that these things are wildly popular. There's a lady just there.
Are you keeping the internal forked versions of the open source code that you use, or are you typically always trying to use the latest? And in particular, I'm interested in those OS components that are core to the driver infrastructure. So not so much on the testing side, but more on the core to the app.
Okay, so do we use forked versions of the applications? Do we stay up to date? And how do we decide to make that choice? Okay. We occasionally, so maintaining a fork is a real commitment, right? And so as a rule of thumb, you do not ever want to maintain a fork of anything ever. You want to use the official version. We do temporarily fork for a bit. One example would be ProGuard, where we forked it recently. We increased performance by 2.5 times in the particular use cases that we had. And the way that we handled that was we then upstreamed those changes. If you download ProGuard 5, you actually have the Facebook changes in the official version of ProGuard. And so what we do is we figured out where the problems were, fixed it, gave them back to the community, and then we try and use the official versions of the applications. We use Guava quite a lot. We tend to sort of figure out other bug fixes we need, are there new features that we want, should we just upgrade because everything else needs the latest version of this? My personal preference is to try and stay sort of with the latest, greatest version. But as a company, we're quite shy about maintaining internal forks of things. Like if we do fork something and it's open source, we tend to make that available through our GitHub repos. And the idea is that ultimately we try and upstream all our changes so that people can take advantage of them. Okay, We are basically out of time right now. I'm going to be around for the rest of the day, so feel free to come down and ask me any questions if I haven't had a chance to talk to you yet. Thank you very much.